all my friends are simps.
In the wonderful world of video art, or at least analog video art, one of the most commonly used tools that you see people with are these circuit bent video mixer devices. And these essentially are just old consumer hardware units that I think people used to, try and jazz up their home videos or whatever they might have been doing. And in these video mixers, some of them have got enhancement circuits. And those enhancement circuits basically let you change the saturation, the contrast, sharpness, and all that kind of regular stuff. But you can manipulate and circuit bend those particular parts of the circuit so that it, produces these kind of wild and unexpected effects. Now, there's a whole bunch of people out there that make these or modify these old devices, including people like the infamous Tachyons Plus. There's also Mezcalin in Germany and someone called Pushkar Brand who was in London, I think, but is now in Rome. But there's a whole bunch of these people around, and this is something that if you're getting into video art, you'll probably see kicking around. Now, these devices are amazing, but they are quite expensive, mostly because they're boutique things. It's quite hard now to find the original hardware with the circuits that produce the best or most interesting effects. And also it takes a lot of time and skill and knowledge to put these things together. So being somebody that is eternally curious, I wanted to see if I could circuit bend some of these things myself. I've not always been all that interested in circuit bending, at least when it comes to audio, because I feel like the outcome of circuit bent audio stuff isn't always as pleasant or as useful as, say, circuit bent video is. So I've kind of just dived into doing this without too much circuit bending experience, but I decided to try my hand at it. Depending on the region you're in, you'll be able to get different video mixers, because obviously in America you're going to have quite different bass units because they run on NTSC instead of PAL. The voltage is also different. But also within Europe, certain countries have different manufacturers that mass produce stuff. Now, the ones I've been looking at specifically are mixers called Vivanco Mixers, and I've got one here that I'll show you because this is the one that I've been working on. And it's just this wee tiny weird looking video mixer thing, and you'll see I've added in a bunch of knobs at the bottom, and we'll come on to that later. But these ones in particular are good for circuit bending because, one, they're still quite cheap. You can find the Vivanco VCR video stuff for like £20 maybe, although there's a few more expensive ones. But these particular ones are especially good for circuit bending because for whatever reason within the case, there's a whole section or bevel at the bottom which lends itself beautifully to just inserting a whole bunch of new components. Whereas with other mixers and stuff, you might have to modify the PCB a wee bit or kind of cram things in to fit. So this is the first one I've tried, or at least it's the first one that's been successful. I did do another one previously to this, but I really didn't have any knowledge about what I was doing, and I sadly blew it up when I came to do the final steps. But this one has actually been successful, so I wanted to show you what I've done and what the results are like. Now, when you're circuit bending a device like this, there are certain methodologies that you should really adopt so that you don't blow yourself or the device up. And one of them is to open it up, identify all of the different IC chips that are on the PCB, look up their data sheet, and then work out which pins are the power and stuff so that you know to avoid that. Because if you connect the power to other pins, it doesn't usually end well. However, this was my first device, and outside of knowing to avoid the power lines and stuff like that, I kind of just dived in. And so I took a couple of these things, alligator clips, and I joined points on the PCB until I got some interesting effects on the video that was inputting at the time. And then, taking a tip from Simon the Magpie, I used these paint markers to mark individual points on the PCB that worked well together. And then all I did was connect them up through different potentiometers and stuff. And I have this kind of breadboarding thing here, which is basically a bunch of potentiometers of different values. And then I would check which one worked the best for which bend, because if you have like, I don't know, a 2K pot, that doesn't necessarily always give you the kind of range you wanted. And I spent quite a lot of time figuring out the best range for the best bend and everything. After that, all I had to do was drill the holes in the case again and put everything together. Now, I learned a few things along the way doing this. First of all, as I mentioned, I did spend quite a lot of time figuring out which resistor or which potentiometer value would be the best for which effect. And actually, in the end, that didn't really matter, because when you have one effect, then yeah, the range does matter. But when you get in at the point where all the effects start to kind of blend together and you get kind of unexpected results, then the range on the pot might be different, because that will affect a different part of the circuit. So whilst it's worth figuring out a rough range so that you know the kind of limits and whether or not you can keep the clean video signal in with your potentiometer, it's not something that I think I need to worry about too much going forward with my other bends. The other thing is that when you're trying to do video circuit bending, you will come across these effects that are amazing, and then later on you'll be like, oh, I couldn't get back to that particular effect. And that's partly just the nature of the beast, because everything kind of interacts with each other as you build things out. Then that's just how things go. And so you shouldn't get too precious about the particular effects that you find early on. It's kind of just an experimentation, creative, unpredictable mess. The other thing that's worth noting is that the front panel knobs actually have a big effect on the circuit and the effects you get. So it's not just the potentiometers and stuff that you add in that have a crazy effect, it's also the pre-existing controls. So if you turn up the color knob on the enhancer unit, for example, then that's going to have a wild impact on the rest of the circuit. Now, I'm just going to plug this in and show you some of the knobs that are on the front. There aren't a huge amount on this one. I think there's like 1, 2, 3, 4. There's 5 on here, and there's 2 switches. And I could have probably squeezed some more in, but since this was the first one I'd done successfully, I just wanted it to work. And I've got some pretty cool effects out of it, so I'll hook it up and I'll show you those, and then, yeah, explain the rest. Okay, I've got my stuff set up so I can show you how this works in practice. The way the signal flow goes here, I've got a crappy kind of car reversal camera that I got off AliExpress for £3.65. It is then going into the video mixer here, and then the output of that is going on to this Ferguson CRT TV, kind of a strange TV with both a DVD player and a VHS player, which is rather unusual, and also does NTSC. Anyway, I'm recording the output of the CRT TV using my Sony A7 camera down here, and the reason I'm doing that and why that's important is because you can capture the glitch visuals using like an HDMI capture card or something like that straight into your computer. But if you do that, you tend to need something called a time-based corrector, and that's because when you start to glitch up signals, it can drop out when you digitize them in that way because it can't really lock onto the signal properly. You don't have that issue with a CRT TV because it's a whole analog signal path and it just displays whatever's on there. So that's why lots of people who do analog visuals prefer CRT TVs. Now, I'll show you essentially what some of these knobs do. Because of the nature of glitch visuals, you'll have to bear with me because it's not always easy to reproduce different things. But I have 4 knobs over here. I've got one also down here, which is slightly hidden off the camera. I've got 2 switches, and then I've got a jack, which I'll tell you about after. But you'll see the picture on here begin to change as I adjust this. Some of the effects are quite subtle, so here you can see it starts like a wee bend that ripples out the way. You get some colour distortion there as well. This one gives us this wild line effect, which is actually one of my favourite effects on the whole circuit. And of course, you can mix and match these. Quite quickly, you get these wild effects. I kind of like the line chroma thing on this. Now, the interesting thing is, even on devices which have the same kind of enhancement circuit, there are differences, and depending on the arrangement of your knobs or your modifications, everything can look very different indeed. So even within the one circuit, if you do the same kind of bends multiple times, then you can still get some wildly different results. So there you go, that's the kind of basic stuff from this side. Now, I believe, as I was mentioning earlier, if you use the original knobs here for the enhancement unit, you can start to get, you know, even crazier effects because they do still impact on the signal. Weirdly, and I don't know what I've done, but the headphone audio input or volume level also distorts the signal. So I must have joined something up by accident with that, but it's pretty cool. Now, at the moment, the enhancement circuit isn't really engaged fully. So on some of these Vivanco things, you can turn the enhancement circuit on or off, but on some of them, it's just on all the time. But I've added a couple of switches that kind of fucked about with the enhancement circuit quite a lot, and you'll see that when I turn it on. This gives us this kind of messed up split line between the enhanced circuit and the original. So you can see that kind of row of dots across the screen. And this means we can get some really weird shit on the go. Like, turn the color up or down. One of my favourite things is when the colour gets really messed up, because that's particularly interesting, I think. And of course the other thing is this fade-in T-bar knob thing, I guess it's a fader, it has quite a big impact on the circuit as well, because this basically controls the amount of the video that is being faded in or out, and depending on how weak or how strong the signal is, you can start to get some really wild kind of rolling effects and everything else. Weird inversions. Ooh. So you can see if I have the video signal at full strength, it's kind of messed up, but if I pull it back, you can begin to really take advantage of some of the effects like the ghosting, the inversions and the lines, contrast. If I turn the colour up, we get different lines. Aye. Now this particular bend tends to go down this liney route, which I am very pleased about because I think that's a really cool effect. It's not so much a kind of wild, colourful bending machine, but it does give you these really weird kind of scanline things. Now the other knob on here engages another part of the circuit, which really makes things get a bit wild. Yeah. Yeah, see, this is the one I like a lot where the colour gets fucked up. And it depends massively on these. Oh, shit. How did I get back to normal? One of the things that I fucked up when I was doing this was I put the potentiometers the wrong way round, so they don't all necessarily go the way you would expect when you want to kind of turn off the effect. And that is a fairly important thing, I would think. So that gives you an idea of the basic kind of effects that you get on this. It's not got the widest range in the world, but it does give some really quite interesting glitchy stuff, especially the lines, which I'm a big fan of. Now there is one additional feature that I added to this, which is something I learned how to do specifically for this project. And that is, if you can see down here, maybe I'll shift it up a wee bit, this wee jack here, this is a 3.5mm mono audio input jack. And what this does is allows you to have some kind of audio reactivity within the circuit. And so basically I can feed in an audio signal and that will change parameters on the circuit itself, which is awesome because then you can take like a track out of your DAW or whatever, feed it into this, and it'll glitch up in time, or at least that's the theory of it. Now, as I mentioned, I had to learn how to do this for this project, and it's fairly straightforward. You use something called a Vactrol, which is where you take an LED and a photosensitive resistor, and all the photosensitive resistor does is essentially act like a potentiometer, except it's triggered by light. So the more light that it gets, the more resistance there is, or the less. I can never remember which way around it is. But you use the LED connected to the audio input jack, and that means that whenever it gets an audio signal coming in, it lights up the LED, which then flashes on the photosensitive resistor, and then you get the effect, which is pretty cool. Now I'm going to turn it on so you can hear what I've got. I've basically got a big stinky kick drum. Okay, you can hear my big kick drum in the background, and I've got a mono cable coming out of my Euro rack, and I'm just going to plug it in, and yes! Now obviously this affects one particular part of the circuit, so it depends on the rest of the knob positions and stuff what kind of effect you get, and it can be more or less extreme. I like this one a lot. Of course, the same principle applies when you have a different sound. So I've set up a hi-hat now, and I'll plug it in, and you can get some really wild... Oh God, I look like it's doing some weird shit to my face. Now, as is the case with all of these kind of glitchy boxes, the input source you use greatly has an impact on the kind of results you get. So if you're using still images, you'll get quite a different look to if you're using a video input, like a, I don't know, composite video camera or whatever. But also the colors of the input will, you know, change the output you get massively. So for example, if you're using something that's quite desaturated, like one of these cameras, or like VHS-C or something like that, then you're obviously not going to have quite the same kind of level of saturation and, you know, interplay between the colors that you might do if you're using like an HDMI media player thing. The other variable here, of course, is the TVs and what you're recording from, because depending on the TV you use, you might have like really saturated colors on one and then not so saturated colors on another. If you increase the contrast and stuff on your TV, it can make a huge difference. So I've got a few different TVs here that look completely different with these devices depending on, you know, the input source and all the rest of it. That's one of the things I actually find really exciting and interesting about the analog video world, is that the end result isn't just determined by any one piece in the chain. Each part of your process or each part of your signal flow will impact the end result, which is really cool. So for the final part of the video, all I'm going to do is play out a bunch of different experiments that I've already recorded. Most of these are using still images from my digital camera, so they're much more colourful, and the results are quite different to what I've been able to get with this wee camera here. So hopefully that was interesting. Folk have asked about if I would make these and sell them, but not just yet, because I need to kind of get used to circuit bending stuff in a much more consistent way. But who knows, maybe in the future I'll make some more of these, and you know, if you want them, let me know. Goodbye.